That's right, we have an online audience, I forgot. Yeah, I just wanted to check to poke my head out here. Oh, David, hey! Nice to meet you. David, how are you?
All right. How's everybody doing? You can hear me all right? So we do have a online presence, and so we didn't want to wait too long in case there's people online. Now, can you tell if there's people logged in? There are. All right. So welcome to the Open Compute Data Center Project Workshop. This is probably the third or fourth that I've hosted. One in New Hampshire. We've done it at the Open Compute Summit in San Jose, Santa Clara, and also done it in London last year. And we're going to do it again in London this year at the DCD there. To introduce myself, my name is Rob Bunger. I work for Schneider Electric, and I've been doing the Data Center Project Lead for about a year now, so I kind of only halfway know what I'm doing. So don't expect perfection out of this project lead. So I first wanted to go over the agenda for the day and see if you guys had any questions. So I'll introduce myself and go over a little bit of our charter. The first bit of work that I want to cover with you guys and the folks online is this Colocation Facility Guidelines for Open Compute Racks. And this is an initiative kicked off about a year ago. Things never go as quick as we had, and it's just about, it's finished. And we'll cover what that's about and get some input from you guys. The next one, Keith Sullivan, he probably won't be remote, but he's done all the work for it, but I'm going to go through it here. It's kind of the next phase of this work is turning these guidelines into really an assessment process. So if you go to a data center, how ready is a data center to support Open Compute gear and support the Open Compute tenants? Then Zahl is going to talk about the Romonet Site Analysis Tool, which I guess is brand new as of this morning. And then Mike's going to cover a proposal that's just about to get approved. That's a color-coded cabling proposal, and it's something that Fidelity has been using for quite a while. We'll take a break, and then we're very excited to hear from Alibaba, who's going to go over some of the work that they've done in liquid-cooled data centers. And at the end, we're going to have an open discussion and talk about potential projects or issues that you'd like to see addressed within the Open Compute data center project. How's that sound? All right. At some point, we do have a couple of foundation folks in the back of the class here. If you guys want to introduce yourselves real quick.
Sure. Steve Helby, I'm part of the Open Compute team focused on supply chain and the solution providers.
All right, that's Steve Helby for those online.
I'm Rocky Bullock. I'm CEO of Open Compute. I have an airball over here.
All right, the big guy Rocky Bullock's here too. So we're lucky. All right, so the data center project is a little bit special within Open Compute. Most people are really familiar with the IT hardware, some of the networking gear work. But the data center project has been around sort of since the beginning, and it kind of got kicked off when Facebook said, hey, we built this new data center in Prineville, which is pretty efficient, and here's how we did it. And they just kind of submitted like the rough design of their air-cooled data center and the electrical infrastructure. And so that we're continuing to gain momentum within this project, but this is our scope right here that hopefully you can see there. So I'd like to say it's everything from the rack out within the data center. So the power infrastructure, the cooling, the IT space layout and design, and a lot of this is going to also include, you know, we've had a lot of on the telecommunication aspects on how you might do run your cabling, facility monitoring, control, and then facility operations. And a lot of folks that aren't super familiar with Open Compute might not know the tenets and what Open Compute strives for. Efficiency, being able to do compute at scale efficiently, openness, right, sharing of designs and being a good community member, and then having a strong impact on the community and driving this stuff forward. So as we look at the work that our project does, we try to make sure that we line up with some of those tenets. All right. So with that, I'm going to stop screen sharing. Well, I'm going to continue to screen share, but I'm going to switch over to the first document that I want to review with you guys. And I do want to say this is a workshop, not a presentation. All right. And so workshop connotates that you guys can participate and you can challenge what's up here and ask questions. All right. All right. We're all friendly. No dumb questions, the whole deal. All right, let me. Come on, where it is. Graphic options. Sorry. All right, so this is should be close to final. So what we're going to do is cover this, again, a body of work that's been done, and it's been mainly done by this team out of the UK. We were lucky enough to have a group of folks that got very interested in you know, Open Compute gear and trying to take the mystery away of how you might deploy this weird rack of IT stuff in a traditional colocation. And the other reason we wanted to do it, and the foundation supported this, was to try to, you know, take all the good stuff that's happening in Open Compute, make sure that anybody can use it, and that colocation facilities are ready for it. So there's two parts to this that I'm going to show. It's just a general document that covers Open Compute, and then rack and how to deploy it in a facility and some best practices, and then there's a spreadsheet that is sort of like a checklist. And the intent is this would be a good document to be a basis of a discussion that an end user would have together with a colo operator before they deployed gear. All right, I'm going to do a show of hand. Oh, one thing I want to point out, so if anybody online has any questions, I think through the, is it GoToMeeting that we're using? Is that right? You can put in questions. And I'm going to leave time at the end to address anything you put in. So it's kind of cool. You're anonymous. You can ask questions, and we'll get to them at the end. All right. So the scope of this thing, they first wanted to keep it to IEC, kind of European, or let's say everything but North America data center document, just because those people had experience, and just to try to coordinate the guides there. So, but it won't be too much to actually make it global. The other thing is at first we were going to focus purely on Open Compute Rack version 2. But decided just because it wasn't too difficult to expand it to the 3 types of Open Compute racks. I'm going to do a survey here. This is audience participation. How many people know what the 3 types of Open Compute racks that are kind of defined? We have a half a hand. Well, yeah, you guys aren't allowed to answer in the back. So, and this is, again, part of what I do. There's 3. Everybody in their mind has the, you know, the version 2 rack, which is instead of 19 inches, it's the special 21 inches, and it's not regular 1U, but it's 1OU, that has the centralized power supply with the batteries integrated with it. And that is the one that's gotten the most press, but there's actually 3. So we'll talk about that. That we'll call, I think, Open Rack version 2. within the past, maybe a year ago, I might have the timing off, there is a CG OpenRack 19, and the CG is carrier grade. So the telco group went off and said, hey, we need some gear for us, for telco applications, and they decided to put it in a normal 19-inch rack, so the servers are all set up to fit in a 19-inch rack and still has a centralized power supply. And I believe it still has a common 12-volt bus bar in the back. And then last year, you might have known that Microsoft made some news with Project Olympus. And so Project Olympus is a server that goes in a traditional 19-inch rack, but it's a little bit special in that it does have internal power supplies versus the centralized, but they're three-phase and they're redundant. It has a special rack PDU where it's blind mate plug-in, so it still is this kind of front access type of thing, but it's a platform that can be innovated within the framework of this Olympus. So there's three, all right? V2, did I get that right? You guys, okay, all right, good. V2, carrier grade OpenRack 19 in the Project Olympus. And there might be more as we go forward. All right, so you guys failed your first quiz. So the other thing we're looking at with this document is when you look at, say, the worst case of open compute gear that you can deploy, it can be very dense and very heavy. If we were to say, for you to deploy open compute gear, you have to be able to take 36 kW and 1,400 kilograms per rack, there'd only be maybe a handful of colocations in Europe that could actually deploy that. So they just said, well, let's look at maybe what potentially might be a lower end, and but explain the full range of stuff. All right. So pretty straightforward. We have the scope of the whole thing, the license, system overview, and fun definitions, and then we get into some architectural stuff. So I'll get through this here. All right, so if you're gonna, the document is really intended for an operator who doesn't know much about open compute, but if a customer said, hey, I want to deploy an open compute rack in your co-location, I was like, okay, great, what really does that mean? Is it different at all from regular IT gear? And the general differences are the racks arrive, usually they come pre-integrated, right? They're fully loaded, so it's not going to be an empty rack which you populate on site. It could be a full rack of IT gear. So there's definitely considerations you got to think of there from a loading dock perspective, the pathway to the data center, and the floor loading of the data center. Okay. They might have a battery installed within the rack. So if it has its own UPS installed, then you wouldn't need something upstream. So does colocation, can it provide kind of a raw power feed to it? Because you wouldn't want a UPS and another UPS. And again, density from a heat removal perspective, can the colocation do that? So those are some of the major differences that you would see. And so this kind of goes into each one of those subsystems. And I'm not going to go through the definitions one by one. You can check out the document on your own. There is Zahl will appreciate this, right? It's done by a bunch of guys in the UK, so they spell some stuff wrong in here. So they put their ERs backwards and things like that. So I let it go for now. In Celsius, why would we use that? It's very frustrating to have to deal with imperial units. Or in my company, so how are, I'll ask, anybody UK people, how are like air conditioners in the data center rated within, in Europe? Well, like how do you see that? KW, right? And that's kind of cool, right? Because KW of heat and KW of cooling capacity, and the math is crazy simple because it's the same units. And our CTO would always make a joke, when we were coming out with units, and we would actually rate them in KW and then have tons of cooling afterwards. And he'd say or BTUs, right? He said the British don't even use the British thermal unit anymore, right? We're the last ones here, so it's very frustrating. All right. So you'll see a lot of metric in here. So pretend you're in science class. So the data center access, and we'll go to the spreadsheet at the end, but it's we kind of have a must-have type of thing and a nice-to-have. So the must-have sets out the minimum requirements, and that's acceptable, and then some optimum requirements. You know, this is to give an idea of how these things could potentially show up. There's all sorts of little horror stories that go along with things like that. If you have an open compute rack that's fully integrated in a crate, is there a ramp that comes with the thing, and can you get it out of the crate easily, right? People have already had stories where they didn't have a ramp and they had to try to figure out how to get the darn thing out of the rack because it's not a light piece of equipment. And then the pathway to the data center. Some of you might have seen ramps like you see on the right-hand side, that there's no way a couple of people are actually going to be able to push something heavy up a ramp that's looks like almost it's a 45-degree angle, right? But what's an acceptable ramping? And then the loading of your, if it's going on a raised floor, there's the dynamic loading of a raised floor as well as the static loading. And so how do you get the actual rack to it? Okay. So the checklist talks about that, and then also talks about some typical height requirements and all that. So here's another, this is actually a trick question. How tall is an Open Compute version 2 rack? What's its height spec? Trick question. So there is no height spec. It could be any height, right? So when you look at the latest revision of Open Compute version 2, it can be a tall rack. They really do the width and the depth and all the other things, but it could be any height. But in any event, this kind of gives some typical best practices with regards to the height of the stuff. All right, cooling. So, the Open Compute stuff, this is the easy part because it's nothing too strange right now. It's front to back cooling, just like most of the other gear you're going to have in a colocation facility. It could be higher than normal. Having a couple of racks that are higher than normal density isn't a big deal, but if you roll in 20 or 30 of them, you got to make sure that the facility can handle that. And the other thing is matching the heat that it produces also with the airflow. So the Open Compute servers on the spec of what's the delta T across the equipment, as well as the airflow that's required. And sometimes it can be, they can operate at a bit higher temperature and potentially lower airflow. And so you'd need to be able to match that. The other thing from a cooling perspective, we say that from a best practice, especially based upon a lot of the things that these guys like Facebook have learned, should be able to be deployed on a hard floor. Containment is a best practice. Hot aisle containment would be ideal, but any containment is better than none for sure. And so we'd look for a data center that has that. The electrical system is pretty straightforward. Except for, I think, all three variants, you're going to want to bring three-phase power to the rack, because most of the rectifier systems are going to take three phases in. So like a three-phase 32 amp feed is going to be typical. So you can get away with 16 amp, 32 amp would be optimal. In Europe, in the US, it would be 20 amps or maybe 40 amps. But this isn't updated for the US, but the special thing in the US would be 277 480 right to the rack versus 208 120. You could do the 415 240 thing also. Now before I go crazy here, just to get people's general background here. Now DCD, I don't know if people are coming mainly for DCD and kind of checking out the OCP thing. It's usually a slightly facility-ish oriented show. How many people would be on the IT, more on the IT side of data center ops or design? Show of hands. 2, 3. How many would be more on the facility-ish side? Okay, cool. Not half and half, a little more in the facility. All right. So the biggest change in the facility from a power distribution design is the ability to bring non-UPS protected power right to the rack, if the rack is brought with a battery backup unit. And then the key there is the generator startup time within the specification of the holdup time for the BBU. Pretty easy to figure out, but that's an interesting way that co-location facilities could differentiate themselves to have that option. And from a telecommunications perspective, there's a lot of work here, and a lot of this is just best practices, but this has a case study or a reference design of kind of leaf and spine type of architecture, and this is where you guys can kind of, I'm not a networking guy at all, so don't ask me any questions on that aspect. But this shows some examples of what a set of open compute gear might look like from a networking perspective. Be ready for overhead design. Also, you know, the interesting thing is everything for open compute gear is in the front, so all your networking connections for the servers and everything in front, so how you bring the cabling to your rack could be different than what you're used to. Okay, so here's the appendices. So this introduction, this has, as best as we could do, a description of the 3 different types of open compute rack here. And then shows the examples that we have, the principles, what those mean, and then a lot of great stuff on the cabling plant overview, all right? And talking about an example of what a large deployment of leaf and spine could look like from a cabling perspective. All right. And then K-array metrics, which I really don't know what that means. Anybody? I think it's just understanding the number of ports that you might have and how it aggregates up. Great. And that is, out of those examples, pretty much it for the document. So we believe it's close to finished form, and then I'll go through the Excel spreadsheet that we have that's a kind of the checklist you can use that backs up the description here. So, comments. Anybody here like kind of unfamiliar with open compute gear? You think this would help a colo operator, doesn't know much about it? Better than nothing? All right, all right, I'll take it. I'll take it.
So just to get a little bit of the conversation going.
Yeah.
Question that sort of come up in the facility side, IT side. The handoff between facilities and IT now is starting to change hands. It's always been power supply has been in compute, and compute is owned by IT, so the power supply is responsible by the IT guy, so if they go bad, it gets to be replaced by whoever. On the facility side doesn't care, he manages up that clock, and that's the demarcation for him. Now with open compute, it being the bus, bar, and the 3 different, it's kind of sure it was on 2, and I guess the Microsoft one should be different. But regardless, since there's so many facilities people in here, what is y'all's opinion on where that demarcation is?
I'm going to repeat the comment for those online. So the comment was, you know, when you look at the way a rack is made with a 12-volt bus bar and mutualized power supply, and then also the battery backup unit within the rack, what's the demarcation between a facility's roles and responsibilities and IT? Because traditionally IT has been, if power supply fails, it's an IT thing. If a UPS fails, it's a facility thing, right? So where is that demarcation? We had one comment that was still at the plug.
If your operators or IT do all of the PDUs and their power devices, ours specifically is just still at that receptacle. And so we give power to the rack is considered IT as well.
Okay, so everything inside the rack, responsibility of IT? Yeah. Yeah, this was an interesting discussion at the summit last year. People were bringing up, well, what if, what if a battery fails inside one of these racks? Is that, is it a facility thing? Not? What do you guys, any comments on that? All right. So they currently, it looks like, I mean, in my opinion, I agree, it's like at the rack. So if you can bring the bulk power, whatever that circuit is, to the rack, everything within the rack, because it's done by an IT integrator, brought to the thing is the responsibility of the IT department. Now, theoretically, any maintenance or anything that has to be done should be as easy as, swapping out a power supply or a battery should be pretty easy, and that any trained staff in IT could be able to do that. Managing proper, I mean, as long as your run time is maintained above generator start time, then everything should be okay. So I don't know, that's my opinion. All right. I'm going to switch over, if I can find it here, the Excel document. Hold on a second. I thought I had it up. Just so you don't see my file structure there. You don't need to know everything I'm working on. Events. There we go. There we go. How's that look? No, just kidding. Wow, that didn't download well. You know what I'm going to do? I'm going to actually look at it this way. All right, much better. All right, this is tried to take some of that knowledge into a checklist, and again, the idea is that an end user and a Colo can use this checklist as a guide to a discussion. And the categories are everything from quite a bit on data center access. So there's, the way it's structured here is that there's a must-have category, and if I scroll down, there's kind of a nice-to-have category. And this is the simplified checklist. We have a detailed one which has a lot more notes and reasoning on why we decided to do that. And so as we discussed, this is everything from ramp grades to weight requirements, height, all the way in the corridor. Again, this is not a rack you're going to want to have to tip over to try to get through a door to get it where it needs to go. And we tried, one of the things that is difficult in this kind of work group is to try to make sure that this was really talked about the differences in open compute gear versus trying to reinvent how you do any kind of data center. So not that we hit that exactly right, because sometimes this stuff just applies in general, and we're not trying to reteach people how to do data centers because they know how to do data centers, just what's different about open compute. Electrical systems we kind of talked about, kind of give some guidance on in-rack shelf power supply, but that's just going to come with the rack. But it's good information for the Colo operator to know how many circuits you might need to each rack and how big it would be, 3-phase 16 or 32 amp, the type of receptacle it is, voltage requirements, etc. And then cooling system, we talked about maybe some recommended aisle widths and the type of containment you might want. Cabling and pathways. So, oops, sorry about that. It's, open compute is definitely optimized for overhead stuff. So if all the cabling's underfloor, is there a good way to get it to the front of the rack? And then a lot of nice to have down at the bottom considerations for the cabling that are not requirements, but just kind of educational stuff here. So a lot of knowledge in here. This again is going to go up to the incubation committee for approval and hopefully get published here as one of our official first approved products of the data center project. So
does the table go over for power, whether it's bus bar or PDU or something like that?
yeah, it doesn't. No, it doesn't get that far.
Can you repeat the question?
Oh, good thing. Yeah. Does it recommend whether you do bus bar or like a PDU with cabling? And the document does not cover that. Yeah. So.
Does the document cover any guidance for the Colo as to if they have a choice where they might cite an open compute rack in amongst all the others, given that they typically have a higher power density requirement and airflow and so on. So in terms of potentially compromising a more standard environment, there could be some guidance for the Colo about where they might, if they have a choice.
Oh. Okay. Yeah. So the question was, does the document cover or give recommendations on where you might want to physically place it, since it could be different from traditional gear, right? And we don't. Again, it was I think we were trying to weigh, hey, Colo operators operate data centers. They know what they're doing. Here's what this rack is. You would know best. If you're getting one of them, where to put it. If you're getting 20 of them, what you need to do for there. So we didn't get that far. But yeah, I think that's a good point. Like if they're not using containment or the containment's not good, it gets really tricky fast, and I think you know that very well. So yeah. Good. Any other comments? So, I think our operator just walked out of the room. If there's any questions or comments that you have online, there we go. Did we get anything online? Any questions? All right. So what's going to happen? I was going to email me the questions, and we'll go over those. So, as with any volunteer work group, we were really hoping that this thing would be wrapped up by like last January. And there was a big chunk of it done, but, it takes until about now for it to be close to its final format. How many do we have? Can you tell how many folks we have online? Oh, okay, not bad. Now there was a lot more people registered for this than that's in the room, right? I think. It's all right.
So I don't know if they're questions, but they are responses. So we're going to send those to you right now.
Oh, I bet Keith and Alan are online, maybe. Great. Okay. So a facility owner might not be able to monitor power supplies and/or batteries in the case of Facebook the monitoring is done through wedge to or switch. Okay, so that's a good point. So even if the facility owner wanted to own that part, they might not have the traditional monitoring. That might go to that equipment. The other thing that was a discussion was spare parts. And so if you're at a Colo facility and a power supply goes down or a battery, you need to replace a battery module. Who, do we keep spares on site? And that might be actually part of the assessment process that we have on, is this a good co-location? Maybe they have a supply chain or access to some of this stuff. So if there is an issue, they can supply their customers with replacement parts. All right. Was that one? You said there was one more comment came through? Mike, or was that it?
That's it.
Okay, great. All right. If there's no other comments, that's all I had for the guidelines. And if you have any stuff, again, you can email me. While I have you here, has anybody here participated in one of the calls or who has not participated in the project calls? I'll do it that way. There should be quite a few hands that go up. Yeah, you can raise your hands. That's all right. Perkins, I know you've never been on one either. You did. All right, so when you go to the Open Compute website, right here you can find all the different projects, right? So if you go to Datacenter, and the information is right here. So the first thing you'd want to do is subscribe to the mailing list. So you go to this link. You don't email the mailing list to try to get on the mailing list because that never works. So you just go on this click, you sign up all by yourself, you get on the list, and then you're on the listserv. And it's pretty, there's not tons of emails, a few a month, so you don't get spammed by this list server. And for the wiki page has when our meetings are, it's once a month, and where projects are posted and draft projects and things like that. So that's all there. So you can find it on the Open Compute website. All right. So what I'm going to do is just to kind of keep the schedule roughly similar to what they have online, I'm going to take a quick like 5-10 minute break, and then we'll start up and go through the actual assessment spreadsheet. And this is really going to be feedback as a whole purpose. This was built in Europe, and we want North American feedback on this spreadsheet. So I'm going to force you to talk. So 15 after, why don't we start back up? All right. I'll make that note to those that are here. All right. All right. All right, we will get started here. Yeah. Okay, so I have 45 minutes slated for this next one, and I don't know if it's going to be 15 minutes or if it's going to be an hour. So we've got plenty of time to go over this. So this is I don't know this in detail because it was really being worked on up until, in fact, yesterday, to be honest. Now I don't know if he's still online, but Keith Sullivan over in the UK has done a lot of work on this stuff, and he would present it, but he's actually doing a benefit run. He's been running every day, and this is his 1,000th day of running, and he wasn't going to like break his streak to go talk at Open Compute. No offense. So, so in any event, that's where he is. So the follow-on now for the guidelines, so that's for the discussion. This is looking to go down the road of seeing if we can, somehow assess a data center and they can become part of a program so that end users know that they are a friendly Colo that can easily accept Open Compute gear, okay, in some form. And so the team started work on this. This is a work in progress, and so I'm really hoping that we can get some good feedback here. So we're going to walk through this as if we're assessing a data center here. And so let's take a look. All right, so we have different categories just like the guidelines, access, some white space, electrical infrastructure, and so forth. So we'll kind of go through here and see how we go. So building access. So each one of these items is going to give us a score. And you guys can see that pretty good? Resolution's all right? A little bigger? All right, glad I asked. Help me out here, Google Docs. How do I blow it up? Oh wait, it's up here, isn't it? How's that? All right, good for all the old people out there, including me. So one thing I want to clarify that came up during the break. So participation in Open Compute and these things, it's fully open to the public. So you don't have to be this big participating member. People can pop on and off the meetings, and anybody in the public can see this stuff. So so it's good stuff. All right. So building access, loading dock with a lift or leveler, road, level-wise step, threshold free access, or other. So what do you think's more? I'm going to do a 2 here, road level. All right. And all this stuff is going to add up to a certain type of score. Let's see if that changes. Oh, look at that. Interesting. All right. Delivery pathway to goods in. That sounds like some kind of UK speak. Can you translate? Delivery pathway to goods in. Is that like into the facility? Sorry. The loading bay. All right. So this is a height issue. How many people have had to tip racks over to get it to where you need it to be? I've done it. Anybody? Yeah. All right. This gives some access. There's optimum delivery pathway loading dock to the white space. So that's good. So this is after you have it off the pallet going in. Corridor floor loading roll. All right, definitely need to translate. Oh, they got pounds in there. That was nice of them. I'll put that. Unboxing, pre-stage and storage floor, uniform area. And as you go through here, and for everybody that's unloaded a rack and moved it in and things like that, I mean, think of something that might be missing. One thing I'm wondering, and it's not, well, something's wrong here. Oh, I don't want to fail it. All right. There we go. I'm looking at this access level. So these things, I know from a traditional rollout of IT, right, you have all these boxes of IT gear, you move them into Colo, you unbox the stuff, so you have to have a pretty large staging area. And I guess this all depends on how many racks that you're going to get, because they're all going to come in crates. You got to have a spot for them. I don't know if there should be a grade for the amount of area that you have. I don't know. What do you think? Area of the what do you call it? Out of the loading dock or staging area? Staging area.
I'm always a big fan of having something provision for cardboard and waste. There's usually a mountain of this stuff.
Yeah.
You need a minimum because you coming out of the crate, it's going to have to be so much large to be able to roll it out.
Yeah, actually just get it out of the crate, right? Yeah.
There's a minimum staging area.
Good. All right. All right, this is it. So this, you see, we're workshopping now. So this is good stuff. This is the type of feedback that, because we have not presented this yet. This is the first time we've looked at this, so we really want to be critical. You know, what else can go wrong with fully loaded racks? Okay. I'll do that. So the width. So greater than, yeah, that's over 4 feet. That's pretty good. You know, think about these numbers. Do these seem about right? You know, for so a ramp. I mean, I think acceptable is a little bit over 3 feet, and under, that's like kind of under 3 feet. That sound about right for what you would list as that's true. There might be a place you needed to make a pallet, move a pallet, maybe. Okay. Here we go. Landing area of the ramp. So acceptable is, that's almost 4 feet, right? 3.5, 4 feet square. All right. And railings, let's see, 3 feet. That's about right. This is, yeah, that's about 3 feet. Yeah. So that would convert pretty well, I think, to the US. All right. Lifts, where are we here? Hold on. Which I'm assuming is an elevator. All right, weight load. I don't know. I'm pretty uneducated on. I mean, I know there's freight elevators and passenger elevators, but let's see. 2.2, right? You got to divide 2.2 is the conversion. So, so that's the 3,500 pounds is this one. Is that right? That's acceptable. You say that's not good enough?
I wouldn't think so, right? No fully loaded rack about 3,000 pounds?
Yeah.
3,300 pounds.
And so you get that in a person in a pallet jack?
Yeah, their optimum is definitely enough, right? That's more in the, so this 3,000 kilograms is optimum. Their acceptable is over 1,500, which is, I think we're saying on the edge of acceptable.
My last was getting down with a big boy.
Okay. Door height should be the same as the other stuff. That's probably pretty good. And the width should be similar to the other stuff of the door opening. Do the, I'm going to show my ignorance here a little bit. The standard open compute racks, I think as specified, do not specify wheels, I believe. They could just be no wheels on the bottom of them, so. Do they? Oh, it does. Okay. 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 Good. All right. Because that changes the logistics of all this. Now, what would you normally do? Stick them on a, if you wanted to get it off of the pallet, you'd stick them on a dolly or something, or what have you seen in that area? If your rack doesn't have wheels on it, or does your rack pretty much always, you always want wheels on your rack? You always? Yeah, yeah. All right.
Typically, they all have wheels.
There's a special dolly.
Oh, right. Oh, a dolly versus, I was thinking the floor ones, but yeah. Okay. Okay, now, so white space, access floor underneath, clearance, if not used for cooling. All right, so optimum looks like it's in the, okay, 670 millimeters, so I know a typical floor tile is about 2 feet, it's a little over 2 feet. Acceptable is 450, and then fail. So if you have an access floor, does that sound about right? Enough to get cables?
Everything that we ever built is in a 2-foot tile, 2x2, so you can do an 8-tile pitch.
Oh, this is the depth. The depth, if not used for cooling.
Although it would be at least 12 inches for cabling, and then 2 foot for probably the optimal, and then 3 feet is cabling and cooling.
Yeah, so this is in excess of what you said, yeah, so this seems pretty, this seems fine. Okay. Access floor clearance if used for cooling. Now this is a tough one because it all depends on the room size, the number of units, and all that other stuff. So I'm a little bit leery of having a grading on this if they're using it for cooling. What do you? Say that again. You'd agree? Yeah.
And on the other things where it's hot color, where you've got vented tiles, automatically variable tiles.
Right. Yeah.
If you're going into an existing building that already had a 1 or 2 or 3, you still have all that stuff, right? But typically, you'd walk into a 2-foot grade floor, would you?
Yeah, I could almost live with if it's less than 2 feet, fail it, and then other than that, you can't tell if it's acceptable or, I don't know, or optimum, because you could have something that's 3 feet and it's still not good enough, right? Okay. Yeah. Floor rolling load. Dang it. I can't. I'm not a. I don't have a good feel for typical raised floors.
I think that's, so it's 3,000 static, it's maybe like something like 1.5 times the rolling weight rate? Or is it 1.5 times the static weight? The rolling?
That sounds.
Considerably more.
Yeah, right. You have to be able to. Right. Okay, let me take a look here. I want to try to scroll down and see what he's got. There's the uniform load. Uh-oh, I don't know, the spreadsheet broke on me here, hold on. There we go. Let me just put the acceptable one and see what we have here. That is more. Oh, sorry, that's per square meter, and this is just straight up the most you can roll. Access floor rolling load. So is that the way it's rated? Like how much? Like how heavy can be the thing that I'm pushing across the floor? Is that how it's rated? So 1,250 pounds seems on the light side for acceptable. I mean, they have optimum is 1,500. I'm going to check in. I think that's something we got to look at. It seems light.
Divided by 4 as well.
Right. All right.
Is there also a chance we start putting more pillars to it?
Putting what?
You put more pillars on the floor, that all changes again too, right? Because we typically do the 4 corners, and then we do 4 corners plus the center, and then the center of each.
Right. Yeah, whatever.
Changes.
Yeah. Oh, no. Now, do we need... Is it the same? It's the same number. All right, would you, finished floor to ceiling height, okay. So before I go there, so, okay, we've broken it out if it has an access floor or a slab floor. Should we differentiate or just say the floor needs to have this capability? I don't care if it's raised or not.
It's only top 2 that changed, the cooling and the not cold cooling. But everything else will be unsubstituted load should all be the same for access floor slash slab floor.
Yeah. You shouldn't have to repeat it, I don't think.
Yeah, because you're going to have to not answer the question. And protect from in practice spreadsheet, you have to not answer the question. Multiple.
Oh, right.
Combine them, then you answer
It's just everybody gets a score. Yeah, got it. Don't or combine. You know, it's interesting. We have, I don't know, I recently saw a survey with regards to floors, and you know, a lot of the hyperscale guys, you know, especially in the U.S., very large area, slab floors and colos. Some colos are doing it, but still, the popularity of putting in a raised floor and colos and everything is still up there. It's not. I think there was thoughts that the slab floor data center would start to become a majority, but it hasn't yet. All right, floor to ceiling height. So it looks like greater than 4.5 meters is is optimum. Acceptable is greater than 3.1, which would be a little right in the 10-foot range. It sounds like. Is that right? 3.1, maybe 9.5, and then less than 9.5. Sound about right? 9 feels minimally acceptable. It's close.
Normal would have to be 8 and not 11.
Yeah. Okay. All right, electrical infrastructure. Only 3 phase. Oh. Only three-phase. Any ideas on this one? So I understand specifying what the oh, okay. So if you, what if I say it's only three-phase?
It's about a 208 environment.
Well, this is European only
Yeah.
right now. I mean, you could run Open Compute gear off a single-phase circuit, but the circuit's going to be, you're going to have either multiple ones or a very large circuit for the power demand, right? So I'm not sure what the question is here and how it differentiates. Why only three-phase? Like you don't run the neutral to the rack, which would be weird. Other, fail. All right, I'll have to see what they're getting after on the voltage. What would the option, I mean, you could do it, I would think there would be, there'd be one question potentially, and it'd be like voltage fed to the rack, maybe. And it could be, if it's, you know, a single phase voltage might be acceptable and a three-phase voltage would be optimal. I don't know. What do you guys think?
Makes more sense.
Yeah, tough to understand what this means. Frequency, not zero. I don't know. All right. Power delivery. And this is an interesting one. That would be optimum, assuming that you're using the NRAC BBU, but if you don't have an NRAC BBU, then this would be less than optimal. So this is kind of a, maybe, oh, this is if you have it available, if it's possible to do that. And I think this would be, because here's the way I envision it happening in my mind, right? You're going to have a customer who might want to have an open compute rack with just the PSU go into a Colo, and that's what they want. They don't want to have to deal with that. There might be some that do want the BBU, and so I would think this question would be more like, can you support both or just one or the other? Does that make sense? Yeah, okay. Good. All right. Generator startup time. I would think we might want to be a little bit better here. Less than maybe 30 seconds is optimum. I mean, right now, a modern data center, aren't the generator is going to get going and ready to be loaded in about 30 seconds, I think. Because some of the open compute power supplies, I mean, maybe 90 seconds, and so you only have really 30 seconds of leeway here. So I'm wondering if that should be, we just increment it by maybe less than 30, 60, and then 90. Okay. And central UPS, I think, is going to be the same with the other one. All right. All right, I want to get your feedback on this general type of topic here. So if you look at what open compute is going after, right, with efficiency and openness and things like this, this is starting to get to the designed availability that you're looking for, which could be very application specific. And you might be building in your availability in the application. You don't want it in the facility to, so to straight up and say, in this case, n+1 or 2n is better than n+1. I mean, it sort of is. I want to get your thoughts on that, or should this just be customer preference, right? It doesn't really matter. You can be, I don't care what kind of redundancy you have in your data center. Or do we need a minimum? If you look at Open Compute, Open Compute's purpose in life.
It's customer preference, isn't it? If you're on the UPS or not UPS, then it's
It's the application, right? It's the whole heads for cattle.
Yeah.
There's a cattle, where we characterize it to pet care.
Haven't heard that one. Yeah, so some applications, they might say, you know what, this is, I'm doing some high performance computing. If it happens to go down, I'm not dead, it's okay, I restart the process, and they're okay with 1N, they're going to pay less for it, and that's what they want. So it doesn't mean it's worse than 2N, it's just the preference. Okay, that's where my head was going, I just want to do it. All right. Now this is getting into what's, let's see here. So this is getting into some stuff that's what's inside the rack. And again, I'm starting to feel like this is a preference type of thing. If we're going to ask the Colo, what are you ready for? Could you supply 232 amps to a rack? If they say yes, then maybe that is optimum. Maybe it increases their score. Or if they can only do 216 amp. Number of independent circuits. Yeah, okay. And then what? Yeah, if you have these available, which kind of is tied to the one above it. And redundancy, I would take that out because that's an in-rack issue. And again, I would take out this because it's an in-rack issue.
maybe the question to ask there is whether they'll accept the lithium packs in their facility.
That's it. Right.
It will be an insurance issue.
Yeah, that's a good point. Yeah, there is a little bit of hysteria going on in that realm, and for my part of my day job, there's revisions going with NFPA in the U.S., the National Fire Code, or they're doing 855, and was originally written by firefighters, and it's crazy. So we're trying to reel them back a little bit so it doesn't kill data center operators. Okay, so this is the same thing. I think because they really had in our mind, I think the Facebook V1, V2, and I think the options now for PSUs that are being deployed right now are a lot different already. So we might take out these sections, just say what kind of circuits can you provide to the rack, and if you can provide all these options, then you're good. Okay, and I like the question on do you accept lithium ion in the rack? Good. All right. Doing good on time. All right, this is taking longer than I thought. This is okay, rack airflow direction. This is a rack thing, so I think I'd reword the question. Does the facility support front to back airflow? Containment method. So I want to get everybody's opinion on this. So I'm definitely preferential to hot aisle containment, but I think the more important question is how good, are you containing everything or not containing anything? It almost doesn't matter if it's cold or hot. I mean, should we say, hey, hot's best, number 2 is cold, and number 3 is none, or if you have partial containment, then you're kind of so-so.
Should you have something in chimneys vertically as well?
That would be listed as, maybe we should call it hot air containment instead of aisle, because then that would capture that. And really, when you think about it, if you really do it right and you just do containment, one plenum happens to be bigger than the other plenum. So you could call it cold aisle containment or hot, just one's bigger than the other. All right. Any suggestions on this? How would you want to do it? You can get back to me later, I guess, if you want. All right.
I think that's a customer preference thing. I mean, we've had arguments about, it's really a thermal runaway problem. Or which one is better than the other.
Oh, if you had a failure, which one might last longer?
Right.
Yeah. True. So, I agree. I mean, I think bringing the efficiency of containment to the data center is going to be important. You're going to want to know your colocation is doing everything they can to be efficient, because efficiency is a tenet of open compute. So I think containment and open. Hot or cold, I think we can, either one's good, but we need to have it. Minimum cold aisle width. So this would be the amount of space that you need in front of the gear, basically, to, I don't know if I'd put this in cooling or if I'd put it in access, because it all depends on the density of your overall data center and all that stuff. So it's bigger than just, so.
This also depends on whether it's cold or hot. Because it's important from a cooling perspective. If it's cold up, and less so.
Right.
What's the definition, what's the defined depth of
Rack?
servers?
Oh, servers. Oh, Richard, 800? But the overall depth of the rack is in the 1,000 millimeters?
Yeah.
So
That's right. What would be the whole rack itself?
Yeah.
It's 8 or 9 tile pitchwork, so it would be a 4-foot cold out, 4-foot equipment, and a 4-foot hot.
that's optimal.
Optimal, right?
But that 400 should be acceptable. It's a little high.
Yeah.
Colo 60, 36 inches.
Right. I've seen aisles that are.
This is where you need a tray all the way out.
Yeah, that's what I was asking about the sled.
Yeah.
Service that server.
Good.
Hands on the rack.
No.
Okay, good. All right, so this should really, I think, be based around service of the server as the minimum acceptable, and maybe 1,200 would be optimum, I think. Yeah.
This goes back to the same access format with all the design and data.
Yeah, and everything else that's in it. Minimum free width cold aisle inside the cage. Oh, so maybe this is what they're saying is the equipment service area inside of a cage. I think you can simplify the whole thing by just saying minimum service clearance. Okay. And then hot aisle, I think, well, same. Okay, there you go. Yeah, right now, it's interesting. We've had a couple of discussions with the server guys, right? And some of the early material talking about an open compute data center is like, hey, you're going to get more free cooling because the servers are built so they can take a little bit hotter temperature than traditional servers. But there's no real specs written around it, and it all depends on the application and how they run and things like that. So it's of course, more complicated than we hope it is. So this will probably just be around your typical ASHRAE kind of standards, if they meet ASHRAE, I think. Unless there's any other information you guys have. Okay. Oh, yeah. All right. And this is probably, okay, top and front of rack feed we definitely want to be able to handle. I think these are reasonable. And overhead network containment levels. This is out of my area of expertise here, so. There you go.
OS2 and OS3. And it all depends on what speed you're going. OS3 is only going to carry you for a little while on 10 gig and a little ways of 4 gig or 40 gig, and then if you're really going to go to 40 gig and 100 gig, you're going to have to go switch to standard mode.
Yeah. For a colocation provider, generally, right, you'll get your drop from the meet me room, right? And so you just have to have what's the maximum available drop I can get would be this. And now what your architecture would be. Okay, well, in any event, above my pay grade there on the networking. So let's see how we did. All right, we had one thing fail. So this is just a summary of the categories. So I feel like, again, this is the first time I've walked through this this thing. We kind of had a sneak peek last week at our call. I feel like the format is decent, and the categories of stuff. I think we have to tweak what some of these answers. What do you guys think? You go assess a data center and say how good it is to be able to accept Open Compute gear. Yeah,
I think there's a lot more that could be added to the network infrastructure.
Okay. Good. So I can lean on your support for that. All right. Great. The other aspect is, I mean, it's one thing just to say, bring in an Open Compute rack and I can power it and cool it. And then I think part of it is that, like, how efficiently can you do it, and can you do it at scale potentially? And so I don't know if those should be grading criteria. Like, there could be a facility PUE that would be part of the scoring. You want to put your gear in an efficient data center, right? How many can you take? What do you guys think about that? Not specifying the type of cooling or anything like that.
Well, most people have a number or range they go for anywhere when they go into the Colo facilities. So
Yeah.
the question is it different for Open Compute? And I think that's preference.
Well, if so what I was thinking is, if say there's two equal data centers, they have exactly the same capabilities to support an Open Compute rack. One was designed and it's got a PUE of 1.7, and one's maybe got one that's a 1.3, same location. Which one should you choose? Should one have a higher Open Compute ready grade, if that were a thing, than the other one?
Otherwise, the real question is how much does it cost? Does it cost me more to go in the higher PUE one?
It might. Oh, yeah. Well, you think it would. It might not. Yeah.
If you're grading them, if this is a checklist for me going in with the Colo guy, figure out how this would work.
This is a grading thing.
So grading as in we're going to score the Colo?
Yeah. So imagine potentially that Colos could apply for this program, and they can get graded at how good they are, right? And they would earn a certificate or stamp and saying, yeah, the Open Compute organization recommends this facility for Open Compute gear.
In that case, then there probably isn't a Colo left out there that wouldn't want to advertise their PUE on somewhere.
Yeah. And I think we'd want to promote efficient data centers too, right?
I think that's your point.
Yeah.
Is to make sure that the industry pushes towards the efficiency as part of the overall overview.
Right. That's what I'm thinking. It's not just I can power and cool it. It's acceptable. Okay. Great. What else are we missing on this thing?
Costs cost on there?
Power cost.
Per kilowatt hour?
You mean what the Colo would charge the end user?
We just put the cost per kilowatt in that region.
Oh, in that region.
Where it's not what they're going to charge because they're all going to get paid. But it's 13 or 45 cents or 2 cents a kilowatt hour, and that's where that Colo is. Because you start putting what the cost is, then everybody's going to figure out.
Yeah, I mean, we could go so far if you talk about, how green it is what's the mix of energy that they're using, are they purchasing, renewable energy, or is it all coal-fired plants? And you can get maybe they have to report the mix of power that they have.
Give them an extra point for lead certification.
The other thing that was brought up at one of the workshops was spare parts availability and service and things like that. And I think their ability to maybe store and house spare power modules for the client, or maybe spare power battery modules or things like that. Maybe even, do they have a supply agreement with the integrator so that if they want to get an extra compute node, it can be delivered through the Colo or something. I don't know. There was things like that brought up, but that might be a Steve Helvey type of question, I think. Service, spare parts. Good stuff. Alma? Good. All right. Good. I think I used up my time on this one, and let me take a look at the schedule here. Okay. So unless there are any other comments, so I will, for anybody who, I don't know if we collected all your emails and stuff, but if you want to give me your email, we can make sure that you have, at a minimum, view access to these documents, which are online, so you can take a look, give us feedback and all that. All right? All right, so I'm going to turn it over to Zahl, who's going to talk about his site analysis tool. All right. I am pretty psyched to. Were there any questions online or comments?
Okay. So, nobody spotted the error on Rob's templates. 25th of August.
What's today?
It's 25th of September.
Oh, dang it. Totally a month off. Hey, you could have fixed that. So.
Yeah, I could have. All right, so quick introduction of myself. I am one of the co-founders of Romonet. We're a data analytics business focused pretty much 100% on data center market. Been around 10 years. Work with a lot of data center providers all over the planet, colo operators, cloud operators, enterprise operators, all sorts. And we do a lot of analytics around the data center lifecycle, so everything from concept, design analysis, engineering analysis, cost of ownership analysis, through operational live site data analysis. So that's a bit about the company. What I'm here to talk about today is a free tool that we launched. Actually, we launched a little while ago. It's called the Site Analysis Tool. There's a little, if you haven't seen it, there's a little brochure on your chair about it. We have just updated it yesterday, so I've known Bill Carter, the CTO of OCP, for a while. Did lots of work with him while he was at Intel. And he thought the site analysis tool was a great tool for operators, designers, anyone really, that is looking to understand the impact of different designs in different climate locations and so on from a high-level perspective. And he asked if we could add an OCP. So we originally launched this. We had the four main data center power cooling architectures. He asked if we get an OCP style facility to it. So we did that, and the tool's live. So it's available if you just hit your browser to point your browser to sat.romonet.com. As I said, it's freely available. It won't ask you for your name and address or anything. Just feel free to use it to your heart's content. I'm going to just do a little bit of background on that and give you a quick demo. And then again, free to use it as you will. So the site analysis tool gives you 3 different ways to look at and compare both data center archetypes, as we call them, and locations, and how those different archetypes will perform in different locations across the globe. I'll just go back to this at the moment. As you can see, at the moment, the data is pretty focused on North America and Europe. We do have a lot of data for the rest of the world as well, but processing this data and putting it in this tool is a lot of work. So probably for the November OCP workshops in London, we'll have some of the Asia regions and some South American regions data up there as well. We should have that updated by then. So there's 3 different ways of using the tool. You can start by picking a data center archetype, and then the tool will give you performance information of how that archetype performs across all of the locations that are in the tool. At the moment, there are about 91 locations in there today. The other way to look at it is from a location perspective and say, well, I am looking to build a facility in Phoenix, Arizona. How do these different data center archetypes perform in Phoenix, Arizona? So you can do essentially a back-to-back comparison from that perspective. And then the last one, which is the most recent update, is this map view. And you can pick up to, I've forgotten the number now, I can't remember whether it's 4 or 5, either 4 or 5 different locations, and then do a back-to-back location comparison. So you can compare Phoenix with Houston or Madrid or wherever. And then there's a very simple column sort. So the data comes out in the form of a table. You can do a column sort, and you can look at the trade-offs between, so for example, building a particular type of facility in a location that may have very low energy cost, but as we were talking about just at the end of that last session, may have a particularly high carbon intensity of the energy supply. And if your CO2 footprint is more important to you than perhaps your energy cost, you might be willing to pay an extra cent on your energy cost to be, the good citizen from a corporate perspective, as your CO2 numbers are important to your business. So it allows you to look at those trade-offs by simply sorting the columns and seeing, well, which type of design will give me the lowest operating cost, or the lowest PUE, or the lowest CO2, depending on the location. And again, these are all trade-offs, so there's no one perfect location and one perfect answer that gives you the optimum everything, unfortunately. Otherwise, I guess everybody's data centers would be there. So the output from the site analysis tool at the moment is provided as PUE, so it will show you the annual average PUE at a given load. I'll go into what a given load means in a minute. The annual energy cost, that's obviously based on published information around industrial electricity pricing. So if you look at a particular state, that information is published for most places in the world. What you pay, what you end up paying for that electricity is obviously down to whatever deal your business gets, but again, it will give you a guideline and give you an apples for apples. So if I take out the fact that I get a bigger discount than my competitor on an apples for apples basis, their design versus the design I'm choosing may perform better. The total annual energy consumption, total carbon emissions equivalent, so CO2e emissions, what the actual utility cost was behind the calculation, and then what we call a PUE surface plot. And what that basically shows you is what the PUE will be under any external climate, external temperature, and any load point. So PUE being predominantly impacted by how much of the data center's capacity am I using and what is the external temperature. There's a surface plot that will give you all of those.
So that's actually kind of a
data points.
PUE efficiency curve for the data center and also with the temperature.
Yeah, it's a three-dimensional plot. I'll show you one of them. How do we do all of this? So we have a predictive modeling capability that we've been using again for many years. The capability allows us to construct a model of a data center in software. This is, I don't know if I can put my mouse on this part of the screen here. Maybe not. So this is what a data center model looks like. I've just put the illustration in terms of what type of data center that's modeling on the right there. So the software is able to understand how that data center performs under any given load. So it has load loss curves for the equipment. It mimics the control strategy within the data center. We can then put that model in a climate environment and run a simulation using full meteorological year climate data and then get a series of outputs from that. So we run these models for a year in simulation time against the different load points, and then this is how we get all the data into the site analysis tool. So all of the models are fairly simple and straightforward. Obviously we can build any type of model to represent any type of data center, but for the purposes of this tool and comparison, they're all 1 megawatt. So easy to compare, easy to scale as well. So you can get a reasonably good estimation simply by multiplying up the number of megawatts. Obviously there are breakpoints where if you go from 10 megawatts or 1 megawatt to 10 megawatts, it isn't a completely linear scale, but again, it's a good starting point. As I mentioned, the simulations use a full typical meteorological year, so it takes into account the cold in the night and the warm during the day. We're not doing a monthly simulation, we're not doing degree day simulations. It's actually using ASHRAE climate data, 20-year TMY data from the climate locations that all of these results are from. The electrical mechanical systems are at minimum 2 in electrical, N+1 mechanical, so tier 3 typically. There's a lot more information, there's a lot more detail about these on the actual website itself, on the ST website itself, just summarizing them here for you. And then again, specifying a target supply temperature for across all of these facility types, again, trying to keep this as apples for apples as possible. It's highly likely that someone building a facility that resembles a facility that one of the web giants would build, which is typically raised floor, typically indirect air or direct air, may look very OCP in nature, probably are supplying higher temperatures than ASHRAE recommended. But again, for a basis comparison, because we're also comparing traditional chilled water systems in here, those folks are probably more likely to be running a ASHRAE recommended. And the design is essentially a single hall. One of the things you can do on the site, there's a feedback tab. If you guys use it and find that it's useful, or you think it would be more useful if something was added to it, for example, it would be great if I could switch between ASHRAE recommended as an inlet temperature and ASHRAE allowable, for example. Feel free to go ahead and type that into the feedback form, and then that'll give us some work to do for the next version that we release. There's a lot of data behind this, so just over 1,964 simulation years worth of data. So trying to calculate all this manually, well, don't. Some of the things we're adding, so we've added, as of today, it's gone live, the OCP style model based on the OCP data center spec. And as you've said, Rob, there's 3 different rack types. There's some obviously variability and some choice in that spec, so it's not a hard spec, and that's why we've called it an OCP style model. It is based on the V2 rack as opposed to the Olympus or any of the others. We will be adding shortly annual water consumption as an output. I don't think there are many people out there who are not thinking about water consumption as much as they're thinking about energy consumption, and I know most of the customers I work with are busy trading water for energy. And you know, they've got great PUEs and great low energy, but their water bills are now through the roof, and now they're trying to find out where the sweet spot is. And at maybe different times during the year, they want to increase their water and reduce their energy, or vice versa. So water's a metric that will be added in the near future. I've mentioned the new locations already. I'm not sure why CO2 emissions is up there. That's already in there. So any other suggestions as you guys use this, again, please feel free to provide it in the feedback form.
Is the CO2 based upon the utility, the amount of power used?
Yes.
Yeah.
And location.
And the location, yeah. So wherever there's published data of, again, the average grid mix,
yeah,
and that's published state by state in the US, it's published country by country in Europe. They're pretty easy to get hold of those numbers. Yeah, it's based on that data.
France versus Pennsylvania might be 2 different.
Yeah, yeah. So let's switch over and give you a quick review of how this works. Now I've lost my mouse there. Mouse over there. I did make it over there. I'll figure out how I get it back over here.
Yeah, the way I think. It's totally not intuitive for sure. There you go.
All right, there's an easier way of doing this. It's like the reboot, right? When it doesn't work. Okay, so got the mouse back. So I think, let me take that out of presentation mode and then move this. Oh, there we go. That's better. So, okay, I could really do with a mirrored screen at this point. I'll do it this way. So, I'm going to start with, so this is the compare. So this will let you choose up to, again, I can't remember whether it's 4 or 5. I'll just do a couple locations, and then you'll get the results below, and then we can sort on those. So I'll start with that. I was going to try and pick Phoenix. So first set of results, and I was going to pick Helsinki as, let's say Helsinki. Yes. Okay, a bit difficult to see from this angle. Right, so, and then I'll do a sort on annual average PUE. So what you'll see here is I've sorted low to high PUE for those 2 locations. And we should see, yeah, we should see the OCP adiabatic come out top. And again, that's generally because the OCP model in here is essentially a variant of the adiabatic model, which is just underneath here. Interestingly, the indirect one performs quite well in Helsinki as well. So again, the difference primarily being on the electrical system with the OCP system are based on the V2 racks. So it's pretty simple to use. We've got a essentially a utilization selector at the top here. So this is basically saying my 1 megawatt data center averaging a 75% loading from a capacity perspective of that 1 megawatt, so around 750 kilowatts of load. This is what I can expect my annual average PUE in Helsinki to be for an OCP adiabatic versus the other options there. So there's a chilled water, there's an economized chilled water, there's an indirect, and then there's a adiabatic, the non-OCP one as well. So I can go in here and select a lower load point. So one of the 4 load points in there, and that will update the results. Or, as I mentioned, I can look at the PUE surface. So what the PUE surface, let me see if I can zoom that a bit. What the PUE surface does is, so essentially we've got PUE on the vertical axis here, and we've got utilization on this axis down here. So this is essentially the data center being fully loaded, 50% loaded, and then we've got external outside air temperature here. And you can see the PUE under essentially any of those points. If anyone's interested in these and you want the actual data behind the surface plot, then just put that in the feedback form and we'll send you the Excel sheet behind it. But some of the interesting things you'll find here is if you look at some of the way these perform, in fact what I'll do while showing you this, I'll show you some of the...
That one looked reasonably insensitive to outside air temperature.
Yeah.
Right?
Well, what I was going to do, this is really difficult to use while not being able to see it properly, but I'm going to pick data center type, just show you the other way. So let's pick the adiabatic. In fact, let's do it. I'm going to look for a slightly warmer and wetter climate. So
Miami
and definitely not Seattle. Wetter but not warmer. Let's do it the other way around, it'll be faster. Pick the location. So let's go with somewhere like Atlanta, United States. Atlanta. So if we look at, let's look at the OCP on here. Yeah, you can see, so there's again a little bit of a penalty for putting that type of adiabatic data center in the warmer climate. So when you're getting into dehumidification, you are losing efficiency there. So there are more detailed explanations up here of those particular facilities, which will give you a little bit more detail about how those particular models work. But as I said, the tool is freely available, so please go play with it, use it, and give us feedback and suggestions of things we can add to it. But hopefully you'll find it useful.
So we go to the SAT.com.
sat.romonet.com. It's if you've got the little brochure there, the URL's down in the corner. Any questions or suggestions? Happy to take them now. Otherwise, feel free to play. It does work on a cell phone as well, but you don't get the map view.
Is there, oh, it's right there. You have a little explanation of each architecture in there, both from a cooling and power perspective?
Yeah. Yep. The only one that's not there yet is actually the OCP one. That was just because we didn't have enough time to do it by today. Sure. But it'll be up there in the next few days.
Okay, cool.
Yeah.
You mentioned wire usage. Is that already in the tool, or that?
No, that's to come. That's to come next. Yeah. So we're just finishing the device type. It's a specific device type to be able to calculate the water consumption. So we've done that, I think, for 2 of the devices, 2 of the archetypes. So probably by the end of the year, we'll have the water numbers in there as well. Okay, great. Thank you.
Great, thank you. We didn't, I got the schedule for our break is a little bit later, is that correct? Or was that all the DCD people getting out of their talk? Or did we miss a break? Double check. If you're up, right? Yeah. We're still rolling on, right? Yes. All right, I'll just come up to the mic real quick while you're getting set up. So I forgot to check. You did send me a bunch of emails during the last presentation. So we did get some good comments online about the checklist. So let me. So one was, why would a low underfloor clearance be a failure? We only use it at our data center to level the floor, not for cables or anything. So it is an access floor only to level the thing. So that's kind of a good point. You don't want to penalize them if it's not really being used for anything. It says in-rack batteries are very hard to get at the moment and also not economical because of that. So certainly for a Colo, it would be best to go with centralized UPS. So I think we can check on the grading there. That's good. Yeah, it should not fail the Colo for forcing to use their UPS. And yeah, it says you're right. The checklist should highlight optimum, but only fail if it really doesn't match, such as you'd have to tilt the rack to get it through, and that would be a real fail. So anyways, just wanted to share the comments we got online. Right.
So I'm Michael Bailey, Fidelity Investments. Been there 14 years, mostly in the data center space, doing network design, cable design, and working with facilities to implement the 2 of our data centers that we have for the production load of all of Fidelity Investments data center operations, from what you see facing customers. So your 401k, and then all the back office for that. So in that process of going more or less greenfield data center in Raleigh, North Carolina, about 11 years ago, was the first time in 25 years we had the opportunity to pretty much revamp everything we've ever done in data center space. And we went from a sea of cables being done any other way we could possibly think of, guys that have been doing cabling for 20 years or guys that have never done cabling before, just running and gunning and throwing cables out there. And I worked in the data center space in our other facilities in a sea of yellow or a sea of gray or a sea of whatever was the cheapest cable out there. When I moved down to Raleigh from the Northeast, had the opportunity to start thinking of newer ways to do things, and decided let's try something different, and came up with a color code of a rainbow of colors, which was hilarious because I could only see 3 colors. Colorblind, and said, got to make something, got to do something, got to figure out how we can organize this. And it really all came to fruition because the facility side of the house was all color coded. They had a red side and a blue side, and it made a lot of sense. The guys walked into a room, they knew they were in the red side of the plant. And if they walked into the B side, they knew it was all blue and it was the blue side of the plant. And the reason for that is the facility that we purchased down in Raleigh looked exactly the same. You walked into the room, you had no idea. So we did the same thing with the cabling. We sort of followed suit, but there's a lot more communications cabling or reasons for communication, or we decided there was a lot more communications cabling in the reasons for colors in there. So I came up with that color standards, and then we decided about 6 months, maybe a year ago, to start breaking this out to OCP, and hopefully we can get it out to as many people as we can and spread that color standard out for a couple of different reasons. To give efficiency across the board, so technicians could move from company to company to company and all have the same color schema, and it all mean the same thing. Reduce costs, so when a company goes out to buy cabling and asks for the OCP color standard, there'd be plenty of that cabling across, and then we're not all buying the same brand, we're not all buying the same spec, we're not buying all the same standards of cabling. Somebody might buy Cat 5e still, somebody might be buying Cat 6a or 6, and somebody might be different grades of fiber, all that might be all different, but the color code of that cabling could all be the same. And different manufacturers could have the OCP color schema on hand, and we could all benefit from that standard. And we could all go in as a hyperscale organization for that coloring as the thought behind it. And then, of course, understanding a cable and what it's designed to do based off of color has become a huge gain inside our facility. You walk up to a cabinet and it's a sea of different colors. At first glance, it's like, oh, this is a rainbow, I don't know what's going on. But after a week or so of being in there for the first day, you know instantly all the red is the red side of the network. That's the A side of the network. I have an A port down. All the rest of the colors in the cable in this cabinet, I don't have to worry about. Those are all ready. They're all good. They're all done. So now I'm done with a third of the cables I need to look at. Now I'm only looking for the server that I'm going to. So efficiency gains just there immediately are off the table. So these are the colors that we're using today. These are the colors that we're also proposing to OCP to adopt. Like I said before, red and blue, which was the same standard colors that we were seeing that the facilities guys were using for their power plant. We would move those over for high diversity HA pathways on the network side. So if you have a high availability data path, A or B, redundant path, they would be red and blue. Management would be black. So RIBs, ILO, ILOM, whatever you want to call it, out-of-band management connections would all be black. Telephone, I don't know how many people still put telephone lines in their data centers, but we have a couple still. We just went with standard gray. Green for non-redundant paths. That's for something that doesn't need to have any kind of a backup. We found it's also really good to use for sniffer connections. What's awesome about that is if you put a green connection in the middle of a red patch field because you're sniffing it, it's really easy to go back and find it. It's also really awesome when you forgot to go back and get that cable and you walk through your patch field as an operator or manager's operator, you see that green cable and you go, what's that there? And they go, oh, we forgot to take that back out. So that's really great to see that. Pink, that's probably the funniest one here for crossovers. Just a crossover cable between two devices. The only reason it's pink is the guy that ordered the cables for me wouldn't say the word pink, and I made him say pink at least once when he ordered it. Pink's really just for a crossover cable when it's going between two machines that doesn't interact with a switch. And then yellow is a standard standard desktop connectivity for compute to the desktop. Those are all the RGB colors, Pantone colors, and raw colors to be shared with the world. Be whatever vendor you use today, those are the colors that we could find. Oddly enough, pink doesn't have all those colors, which I guess if I would have thought this 10 years ago when I was making a joke, I wouldn't have picked pink. But anyways, those are the colors. There has been some talk why colors are back and forth. Red is the only one that's actually kind of a problem. Fire marshals in some parts of the world will give you a little bit of grief. But what we found so far in the north, south, and even Midwest, as long as it's inside the cabinet and inside the white space of the data center, your fire marshal
won't give you any grief. He's like, okay, that's not in the building, it's not crossing a wall, it's not going inside and outside of a room, I don't care. Now, that may change, and you may find that becomes a problem with your fire marshal. Usually, if you talk to your fire marshal and tell them why you're doing it and what's going on, it's usually understood and things sort of go away. But at first, when he sees a sea of red and he walks into a room, he starts to get a little hesitant. But I think we've talked to overseas, that tends to be the same kind of response. When we get into labeling, the jacket itself, or the plastic label itself on the cable, should have all the manufacturer's normal labeling itself on the plastic label, whatever it is, the brand, the kind of cable it is, and so forth and so on. None of that should change. We're really only talking about the jacket plastic color, instead of it being the 50 different shades of yellow that's out there, or blue or black or purple or whatever color you may be using today. Typically it's a sea of yellow. We're talking about making that a standard color, and then labeling it accordingly with the footer markers and the names and so forth. Then we did get some suggestions on actual labels, sort of standardize on those, but that's really a customer preference on how you'd want to label. But a room destination, a grid location, and then a port number where on both sides, so where it's going and where it's going to. Didn't really want to get too far into that. Labeling is a hot topic, if you will, inside the IT. I'm a big fan, if you look at that second line there, of QR codes and making it a live database. I actually have a system built inside of Fidelity where they're all serialized and it's QR coded and automatically updates, and it's limping along very, very limpy, trying to make that still work.
To that, from a, is it limping along because of habit and people using it, or
culture?
Culture, okay.
It's really culture.
Works and all that. It's just getting
Totally works just fine. As I teaching the old dogs new tricks, using an iPad to scan it, or you even give them the scanner to do something that they've hit print. I can prove that it's 400 times faster to do it and all that stuff. It's just, I've been printing labels for 20 years. Why you want me to change, kind of a thing. So this is what a typical rack in Fidelity looks like. So you can see the red and blue, and we're talking about everything: power cords, communication cable, fiber cables, everything. Patch fields looks like a sea of red and a sea of blue. In the Fidelity world, we do a patch field for fiber, a patch field for copper, and then inside there's availability zones. So Fidelity term, if you will, but it's really two data centers inside of one hall. So two zones separating, so anything can be in two zones. It's ridiculous. There was actually a slide in the earlier presentation that showed that. Regardless, it makes it so that a technician can look at this rack here in front of you and see that, oh, I got a blue power cord that fell out, or the blue power side is down. I know that I have to only work on the right side of the right side of the rack at this point in time. So this usually brings up a lot of comments about different pieces. I'll let anybody, I'll bring it open to questions and comments. It's usually about keeping up with inventory is the first one.
I have a common question. So the inside power, which side, do we regulate which side on the A side, which side B side when you're standing at the rear of the equipment?
So we follow suit with the facility side. So whatever side they decided it was red, then we would just follow suit. So in in this deployment, the red was always on the right.
So the right side is A and left side is B.
Right. And that was just because that's what facilities did. So it could be, it doesn't really matter as long as you stayed true to what the facilities did. You wouldn't want to. And since we did this, and really when we walked in the door of the facility, they had blue and red placards with the PDU numbers and stuff on it. But they still had to run whips from the RPPs out to each PDU. And once they saw that we started doing all the red and blue power cords, they started labeling all the whips with red and blue tags as well. So they then started to adopt what we did. At one point, they started getting custom red and blue conduit and laying it on the floor, which kind of got ridiculous because it's under the ground and nobody could see it, so they stopped doing that.
But you'd have either under the raised floor or above, you'd see a tag on a power cord, and one has a red tag, one has a blue. So,
yep.
So the chances of messing up and putting two A's inside of a rack is pretty small, huh?
Just, yeah, it's very small. And I will say that this has stopped a lot of outages because people will, reach up and grab a bunch of cables and they're like, oh, wait a minute, I'm not even in the right side of the room. Because I'm looking at the switch and it's a B switch and I have a whole bunch of red in my hand. I'm in the wrong place, and they run to the other side of the room real quick. We don't have any incidences of money to prove any of those things, and we just know that a lot of the people have said, this has saved me a bunch of times. We do have all the stories where I don't have the right length cable and I'm aggravated. I have to run back to the cart and get the longer cable. So we have more cables in the room on a nice little cart for them, and we keep the appropriate inventory. We've been doing this, like I said, for 11 years now, and we keep a decent inventory in stock. After about the first month, that aggravation goes away because they realize the benefits outweigh I have to walk back and get the cables. And it's usually the 2 to 3 meter cables is what they use for inside this rack. And after a month, they figure out, oh, I don't need a 1 foot or 1 meter, I need a 2 meter for this length, I need a 3 meter. And any guy or girl that's working in the data center starts to figure out the lengths and they stop grabbing the wrong length cable. And the replenishment happens. And we have an auto replenishment scenario for us. And we've done, we did little baby steps. It used to be, a box of 100 stacked on top of each other in 50s. And when you took the last box off, there was a little piece of paper that said order more cable. And that worked for a little while, and they realized, oh, that was kind of lame. And then what happened is we did run rates, and we figured out what we were normally running out, and based off the number of servers, we needed to order X amount every quarter, and we just reorder based on run rates.
How about the car for do we have any chassis ground in the data center, like the ground cable for the frame?
So the ground cable that we use is just straight copper.
Oh, okay. No shit. Not green or injected.
No, not green. I've seen it green out there, but ours is straight ground. The facility we have is got more ground in it, and it's definitely where you want to be. There's lightning going on, or a storm.
So, one point of clarification, right? This is OpenCompute is not a standards organization, so this isn't being published as a open compute standard. It's a proposal and it's a recommendation of best practice, right? So just as early on, Facebook learned a bunch by making their own servers and contributed that. For 10 years, Fidelity has been using this as an operational best practices, and then is donating that to sharing with everybody. So it's a
So this is the document that's out there. So it goes into a lot more detail about why we're doing it. Anyways, and it'll go through, like you said, best practices, and it'll go through, I don't know what's highlighting, in more detail, and it'll actually show the cables that we're using. It'll go into the fiber piece, and the fiber piece gets a little bit more complicated. Is that fiber cables have always been, designated by the grade of fiber they are, multi-mode, single mode, and multi-modes had aqua and blue and turquoise and all those other things. And we're not saying to get rid of the TIA standards by any means. What we're saying is to move those colors to the connectors themselves, and the jacket color of the cable, which is the most visual part of the cable from afar, and colorize that to the OCP, but then take the connectors and leave those and follow suit with the TIA and not abandon those colors by any means. So if you go farther down into this here, you'll see some examples of colors. And then here's some of the fiber jumpers that we use today. But then if you look down here, here's some single mode jumpers with the standard red and blue jackets, but then with the connectors colorized, so that you know that this is single mode. Because you could imagine grabbing a red cable fiber jumper that's all red from end to end, not knowing if it's single mode or multi-mode, plugging it in and not working, and then scratching your head or breaking the ferrules because you're plugging it into a multi-mode thing that's supposed to be a single mode, and so forth and so on. So you could do then these end connectors could be switched to anything. They could be the multi-mode turquoise or aqua colors or whatever they're going to come up with down the road for the TSA colors could all be adapted as we go down this path. And then there's this example of keeping the text the same on the things, and then this also applies for a twin-ax cable. That's the same there, and of course the power cables. And the hope is if we all come together as a community and all start buying in, then these prices would continuously go down. So I have a provider, obviously, for twin-ax cables and fiber cables and copper cables that would love to, sell as many cables to as many people as they want. They love selling to me, of course, and they like to sell them at a great price. But if y'all want to buy from them, then my price would go down and your price would go at whatever that price would be. And if then 3, then 4, then 5 would be great. But this here, the twin-ax that you see here, is the first real true case study and actual thing that actually has worked. So this is a certified cable that we found 3 years ago when we came out to OCP. We didn't want to buy twin-ax cables from the tier 1 provider anymore. So we went out and actively looked for a new person to buy twin-ax from. We brought them in, went to IOL, certified a couple of them, then tested them internally, picked one, asked them to make them in colors, started using them, and then told as many people as we could which ones we were buying and who we were buying them from. And now they sell these cables to at least 4 different companies, and the run rates that we had to buy, the minimums we had to buy, and the prices continuously dropping down. So we're the least person that buys there. We don't buy as many, we hardly buy any of them compared to other people now. And would like that to continue with all the other cables that we buy, but this is one of the successes of all this, especially out of OCP from us. Any questions, concerns, aggravations? Usually is an aggravating topic for people. I know changing colors of cabling can be annoying.
Is everybody super diligent and has a similar type of scheme, or? Yeah, it's different, but it's different. But you've seen the same benefits. Good. All right, we got to switch to this now.
Cool.
Great.
All right.
Thank you.
Was there any comments back there? Wow.
All right.
I guess we've beaten them down over the last 6 months. Or they're just giving up. Cool. All right.
It's very satisfying for my OCD. It's really.
Yeah. We always joke that we put all our cabling up high and actually hanging on the mini, we call it a mini rack, but they're hanging on the cable tray. And the cable trays are at 9 and 12 foot high. The shortest guy in our group, he's like 4'2" or something. He came up with that, and the colorblind guy came up with the colors for the thing. So completely opposite of ours. So.
All right. Before we go on break, I think you want to introduce yourself and
looking for Bill, but I can't find him. So my name is Archana Haylock. I've met some of you, and I'm hoping to meet the rest of you. I am the community director for OCP, and I just wanted to point out one awesome thing that Mike and Rob are doing, which is contributions come in all shapes and sizes. A simple color scheme guidance document means the world to a community that is looking out there for some guidance. And so you can do a server, you can do a spec, you can do a case study, you can do a white paper, you can do just about anything that would benefit the community. And if it's something that you struggled with, chances are somebody in the community is also struggling with it. So the whole purpose of Open Compute is to diminish the amount of struggling that's going on and get that collaboration going. And so if you've done something that's unique like that and that the community can benefit from, I would highly encourage you to at least participate and join in and post something on the web, on our wiki or through Rob if you can, because I think that's what really helps us make progress and helps us learn, right? So if there's anything I can do to help you in that way, if you're on our wikis, if you're on our website, if you're on our marketplace or on our portal, and if there's a better way of doing it, please bring it to my attention. We are making small changes. You'll see Rob start to use GoToWebinar. In fact, we're using it today for our collaboration tool, allowing people remotely to join in, and hopefully it'll be a lot less frustrating than views. So we're making small steps, and please reach out to me because I'm looking for feedback. If there's anything I can do to help improve your OCP experience, both remotely as well as here at the workshops, let us know. I know registration was a bit of an issue. I've heard that. I've also heard the fact that all 5 workshops are in parallel. That is really difficult for you to try and have any kind of cross-pollination where you're coming in to see multiple events and hear different speakers and listen to different perspectives. So we are hoping to remedy that. This kind of came at us a little bit last minute, so we had to accommodate since we were co-locating with DCD. But any kind of feedback would be really appreciated. You can let Rob know, you can let me know. I'm here, so please, thank you so much for attending. We really appreciate it.
So we'll break until about 4 o'clock, and we'll come back, and I think Alibaba is up.
The first door on the right-hand side after the bank of windows has
Hi, I'm Hedy from Alibaba Infrastructure Service Department. On behalf of my colleagues, I would like to share with everyone about best practice of Alibaba data center and also some viewpoints about immersion cooling. When we hadn't understand internet completely, mobile internet were coming. When we haven't made mobile internet clear, big data and cloud computing are coming. Unconsciously, hundreds of data centers have risen from the ground, and the data centers are producing more and more data. In fact, big data is in our life. It's every day. When shopping, we are used to input the name of comedy and click the search button. When traveling, or some app like TripAdvisor or FlightPick guides us. In fact, from millions of users input something in the Taobao search bar till the transaction are finished, it goes through millions of times computing in data centers. Data center has become into production center from auxiliary facility. Since we cannot live without data center, and we have to study it. There are 4 key points about data center construction. When we are planning data center, there are 4 key points. They are forward thinking of IT strategy, and site selection and critical facility design, immersion cooling, and the intelligent operation. We all know data center consists of 4 layers. Their application layer, operation layer, IT hardware infrastructure, and site facility. So-called forward thinking on IT strategy. We all know data center serves for IT service. So-called forward thinking on IT strategy. It means we need to begin with IT planning. It means we need to sort out the reliability of IT service. For example, there are cloud computing, online shopping, offline big data analysis. After making all the IT service reliability, we get to know the entire reliability level of data centers. Combined with consideration of IT service expansion in a period, we got to know how much IT we should build. And meanwhile, combined with the TCO goal and energy saving target, we got to know the construction demand of data center. The nature of forward thinking on IT strategy is to translate the IT service into some construction demand of data center. That is how much IT, what's the entire level of reliability, CapEx, OpEx, PUE, or WE, and so on. After the construction demand is clear, the next step is site selection and critical facility design. You know, site selection is balance between IT service, government policy, climate zone, network resources, electricity resources, and human resources. Let's take an example of Alibaba Zhangbei Data Center. We can see Chinese map in this PPT. And Zhangbei is not far away from Beijing. That is the capital of China. So the IT service can be deployed in Zhangbei. And the Zhangbei government is very friendly with data center industry. It gives very good price of power and the land. The climate in Zhangbei is very cold and dry, so it is fit for free cooling. And there are good resources, good network resources, and rich wind power. And the human resources are no problem. So Zhangbei is very fit for locate Alibaba data center. For critical facility design, space, power, and cooling are very important systems. For architecture and space design, we generally design the building as two-story. The first story includes the electrical room and other auxiliary function area. And the second room is the data hall. For power supply system, we also have best practice. In most data centers all around the world, the UPS are widely used to provide continuous interruptible electricity to the servers. But the efficiency of UPS is limited by the inverters. Alibaba used 240 voltage DC, and the efficiency is better than UPS, almost 91%. You may say UPS has echo mode, but that's a different topic. You know, high voltage DC is online, but UPS echo mode is offline. And this system is more reliable than UPS system because the battery is connected to direct current. The improvement of power supply system is a good way to lower PUE. So we can imagine if we can eliminate the UPS or high voltage DC from our system, the PUE could be lower. So in Zhangbei Data Center, we have deployed several IT modules to put several BBU to back up the system that diminish the power consumption directly. That's another application we will research in our future data center. For cooling system, we all know the free cooling is the key factor to lower PUE, but the free cooling depends on the climate. That is up to the Mother Nature. Before making decision, we need to analyze the climatic parameters. Let's take Alibaba Zhangbei Data Center as an example. This picture shows 7,360 climatic parameters in psychrometric chart. We can see most of the climatic parameters are located in the allowable area, and most of the climate time is fit for free cooling. Air in Zhangbei is very clean, so the direct air side economizer can be taken into consideration. 4 levels of air corrosion is defined in A3 gaseous and particulate contamination guidelines for data centers. That is J1. That is from J1 to GX. We all know J1 and J2 level of air can enter into the data center directly. After the analysis of Zhangbei's climatic parameter, we gather some results. The average dry bulb temperature is 3.7 degrees C in latest 5 years. Air is clean enough for direct airside cooling in 320 days a year. Our water side free cooling time is about 96%, and direct airside free cooling time is about 88%. But in Zhangbei, water resources are not rich, so we adopt direct airside economizer in our cooling solution, and considering special weather such as sandstorm, water side economizer is also furnished. Finally, we got power usage efficiency is 1.25. From the Zhangbei example, we can see that we have to attach great importance to site selection, climate, and water resources determine if water side economizer can be the choice. Climate and air quality determines if the direct air side economizer can be used. But, always but, Alibaba data centers are all around China because of IT service. Some data centers have to be located in the south of China. For example, Shenzhen, where it is very hot and humid, and the price of power and land are expensive, and air quality is too bad. In such kind of areas, how to achieve low PUE, how to get the optimized total cost of ownership, and how to get the low WUE. This has become a big challenge. When we have to face this challenge, the immersion cooling is becoming highlight. In addition to climate zone, rapid development of hardware is another main factor that drives immersion cooling into application. And this picture shows the rapid development of power consumption of CPU and the increasing of case temperature. Computing drives CPU into higher and higher power consumption. And with the increasing of case temperature, we found air cooling cannot meet the heat dissipation demand of CPU anymore. Of course, we want to lower PUE and optimize the total cost in any climate zone. Let's take a look at rack power density and cooling cost trend. This picture shows that power and cooling. The left picture shows that rack power density is growing rapidly in recent years. The other picture shows that power costs have exceeded the IT investment in recent years. And for the past year, Alibaba's rack power density is 3 to 5 kilowatt per rack. Now almost 7 to 16 kilowatt per rack. In the future, it might be 20 to 45 kilowatt per rack. Then, when we are planning a new data center, how to solve high density racks cooling, and how to lower cooling cost and the total cost, how to achieve low PUE in every climate zone. That is worth thinking. To find answers for this question, let's analyze the cooling solution at rack power density. In this picture, we can see almost all kinds of cooling solution. Cold aisle separation with hot aisle, and cold aisle contamination, overhead cooling coil, and rack level circulation, hot air extraction, in-row cooling, rear door heat exchanger, and cold plate and immersion cooling. We can see with the growth of rack power density, as the cooling source is nearer and nearer to the heat source. Finally, cold plate and immersion cooling should be used to resolve the heat dissipation of servers. But why we would like to choose immersion cooling notch rather than cold plate as high density rack cooling solution? The answer could be found in this table. Air cooling, cold plate, immersion cooling are compared in this table. Air cooling is the baseline. Plus means better, and minus means worse. For cooling capacity, it's obviously immersion cooling is the best. For hardware integration, because in immersion cooling, no need for server fans, so it is easiest for hardware integration. For maintenance, both in cold plate and immersion cooling, hardware need to be redesigned, but the immersion cooling is better than cold plate. For hardware reliability, because the liquid protects CPU from air dust, humidity, and vibration, so the hardware reliability is better. For hardware performance, because cooling helps cool down the chip, so the lower temperature helps improving the CPU's performance. For heat recovery, it's obvious immersion cooling is the easiest. For noise, immersion cooling is the most quiet. For corrosion, because servers is isolation from air, so no problem. So the corrosion is no problem. But for material compatibility, some tests need to be conducted. In cold plate, maybe better, but in recent years, many tests have been conducted in this industry. For initial capex, for now, liquid immersion cooling is the most. For OPEX, the immersion cooling costs the least. For the weight, because the liquid, most of the liquid is heavier than water, so immersion cooling is heaviest. In brief, we have to solve some material compatibility, maintenance, and hardware redesign, and solve the cost for immersion cooling. Anyway, we can say from cooling solution, immersion cooling is the best. We all know immersion cooling is not new technology, but the combination with servers, network switch, cabling, cooling sources, monitor, and control system in data centers are new. Immersion cooling needs no chillers, cracks, server fans, and it can make the cooling system simpler. PoE can be low in any climate zone, even in hot area, and WE can be 0. But the monitor and the control system is different from the traditional data center. So the monitor and the control system need to be redesigned. To sum up, 4 benefits from immersion cooling. The first is density. When someone is designing the hardwares, no need to worry about the thermal issue, and no limitation for rack power density in data centers. The second is efficiency. We can get a low PoE in every place, even in hot climate zone. Of course, the liquid lower chip temperature and makes the CPU computing faster. The third is simplicity, because we don't need the chillers, cracks, no need for server fans, so all the cooling system become simpler. And this simplicity will improve the reliability of cooling system. The first one is scalability. In immersion cooling, it's easy to expand rack density from almost 20 kilowatt to about 120 kilowatt just by replacing these servers. And the modular construction is easier. After design, construction, and commissioning of data center, the operation begins. For large-scale data center, intelligent operation is must to have. This picture shows what a data center includes. There are thousands of IT equipment, tons of mechanical and electrical facility, many kinds of systems, And the data center is a very comprehensive system. It is impossible to operate such a complicated system without automation and intelligent operation. Alibaba makes real efforts to operate data center intelligently. For cooling system, intelligent operation is must to have. As we all know, cooling is different from power system. There are two states about electrical system, which is on and off. But the cooling system is more complicated. In addition to continuous operation, the running mode needs to adapt with the climate changing. That is seamless transition between economizer mode and mechanical cooling. When the city power is off and the chillers are restarting, the emergency cooling source need to take over the cooling seamlessly. When the cooling load varies, and the intelligent and the cooling system's cooling capacity need to be adjusted. All this need intelligent operation to finish. Let's also take Alibaba Zhangbei data center as an example. There are almost 6 cooling modes in Zhangbei data center. There are 4 air-side free cooling, partial air-side free cooling, and no air-side free cooling, and 4 water-side free cooling, partial water-side free cooling, and no water-side free cooling. And how to switch between these 6 modes? We can imagine it is impossible by human's hand. So we did a very automatically control system. When the air temperature is fit, it's fit for direct air-side free cooling. The control system opens fresh air dampers, close return air dampers, and open exhaust air dampers. When SOP of fresh air is less than return air, intelligent system needs to switch cooling system into partial air-side free cooling. At the same time, modulate fresh air, return air, and exhaust air dampers. When air quality is bad or temperature is high, intelligent system needs to switch cooling system into no air-side free cooling, close fresh air damper, open return air damper, close exhaust air damper. All the switch should be seamless. Alibaba attaches great importance to intelligent system and operation. EPMS system manage generators, fuel supply system, city electricity, battery, UPS, PDU, and so on. And the BMS controls chillers, cracks, cooling towers, and monitor the temperature and humidity in cold aisles. Of course, control the free cooling status and denote POE and WE, and fire and security control. Manage the fire alarm and security alarm. Finally, ITSM is in charge of configuration, event change, process problem, knowledge service management. Only by this intelligent system, we can improve the efficiency of operation and reduce the human error. In brief, when we conduct well in forward-thinking on IT strategy, site selection, and critical facility design. Adopt immersion cooling for high-density racks and furnish intelligent operation system. The data center can be base of cloud computing and all other IT service. That's all for some discussion. Any question or some discussion?
What percentage of the compute in the Genbei data center is liquid immersion cooling, and what percentage is traditional racks?
It depends the IT strategy of every phase. So we will sort out the heat load of servers.
Okay, so you're only using liquid immersion cooling for the high density servers, and is that all, is the entire data center the high density servers, or do you have others that are traditional air cooled racks?
Combined, of course, combined. Hybrid, yeah.
Okay.
What's the highest power rack you have?
So, pardon?
How many watts, the biggest, or immersion cooled, the biggest immersion cooled rack, how many watts? 120?
12 voltage. You mean electrical voltage or some?
Wattage.
So the most density.
最高的液冷的功率多大？多少千瓦
Uh,
the cooling one is a one-phase liquid and a two-phase liquid. Two-phase liquid, we can design the capability of a tank is up to 80 kilowatt, up to 80 kilowatt. And for one-phase liquid, it's designed for up over about 40 kilowatt.
Mm-hmm.
40 kilowatt operating, and now we have those racks.
We have we have finished that testing and evaluation. We have the skill deployment. Just will complete it in next week.
Okay, so you're in the process of skill deployment right now.
Yeah, so we just went through the pilot phase, right? We are in the deployment phase. Right?
Yes.
So once this is successful, by the end of next year, so we're going to go to the skill, big skill. So that's all I think.
And what's the point where you decide it's feasible to switch from an air cooled to an immersion? Is it 15? Is it 20?
You mean the percentage?
KW.
PW.
So you got a rack out, you got a whole bunch of racks out there, and you got some at 5, and some at 10, and some at 20, and some at whatever. The 15 mark when you start deciding that those need to start being combined and make it an 80 kW rack?
It's also, you know, the IT computing service determines the servers and how many servers in a rack. This determines the, you know, the specification of this IT hall, data hall. Almost 20 kilowatt per rack.
You'll switch to liquid at 20?
We'd like to try it, yeah.
Okay.
Yeah, I can provide a little bit background. Yeah, I can provide a little bit background when we decided to go to the immersion cooling. Because in China, most of the area in the Shanghai, Hangzhou, Xining area is hot and humid. Traditional air cooling won't give us those flexibility, right, for the site selection. So the one major reason is we want to have more choice, right, for the site selection. And we can build a data center in southern China, right, starting in the Shanghai area. Yeah, getting in Asia, the temperature. We don't have a plan to build a data center close to the Arctic area, so that's not our plan. That's the major reason.
in the pilot program, what were some of the challenges of implementing the technology?
What's the challenge we have to implement the immersion cooling tech?
I think just now I mentioned the immersion cooling is not a new technology, but the combination with servers, network, PSU, and the monitor and control system is a integration. So this integration is new. I think this is the big challenge.
Yeah, hearing people, the one challenge I've heard is still having to do mixed cooling technologies in the same data center, right? I got to do, well, my switches and my spinning hard drives still need air, but the servers can be immersed, so now you have to implement a traditional cooling system and your liquid, and I don't know if that's one of them, but trying to work to immerse everything.
Mm-hmm. Maybe for network machines, for now it's a little difficult to immerse it. But for servers and for PSU and for the cabling, I think is no problem.
Okay. Mm. Sounds like we have a project for the networking group, right? In the OCP.
Of course. Maybe the supply chain is of immersion cooling network. I think it's difficult to you know.
Yeah, actually, we put some basically the networking gear into the immersion cooling, but not in the router, such as the basic stuff on the top switch and stuff. Also inside the immersion. Also those high-end routers.
Sorry. With an air-cooled data center, if you want to change out a server, you can do that, open up the door and take it out. With immersion cooling, you have to open up the tank and plug it in. So how do you handle, once you close it, how frequently do you open it? What is your life cycle for refreshing the hardware?
It's a good question. We have developed and you know, of course, we have some co-worker to develop a new machine, just like a mechanical head to, you know, to grasp the server or something immersed in the liquid. It's not so difficult to do this.
Suggestion for future workshops. The industry is dying to learn about that exact question, maintenance and stuff. And so anything you're able to share as you go forward, I think everybody will be sitting on the edge of their seat.
Yeah, we believe we are going to have more insights by experience by the middle of the next year.
Yeah, great.
Mm-hmm.
I have a question. When you decide about your rack density, you could always choose to spread your stuff apart so that air cooling works, right? It's just a, you know, cost of real estate maybe, but sometimes maybe it might make sense to put the stuff all close together. What kind of decision process is there? Certain types of applications where you want the IT gear physically very close together?
Maybe the material compatibility test can give us some hints for the spare parts. For example, maybe some PSU or the heat exchanger or some filter and so on.
Okay. For compatibility with liquid cooling? Or with the liquid?
Yeah.
Okay. Well, so I guess I have to rephrase my question. You could choose to just not make your racks dense, right? Just make them 15 kW and you never go above that. Why don't you do that instead of putting it all together and have to do liquid cooling? Just a kind of hypothetical question on your thought process.
I can answer this question, right? So one major reason is the cost, right? So in the current location, right? So if you decide to build a data center in close location, Shanghai, Shenzhen area, the spend, the cost on the land, right, on stage is much expensive. That's a major one reason. Another reason is from the server design standpoint. So from manufacturing standpoint, from cost standpoint, we have high efficiency from the delivery standpoint. That's the, I think from my view, that's the two major reasons.
No question?
I got one more, sorry.
Okay.
When you have an emerging technology, it's hard to get executives to understand the technology and trust it.
Yeah.
And Alibaba is in business, they have to have uptime. Were you able to convince your executives about the reliability of the technology, and was it difficult?
I think reliability includes the some hardware reliability and the system reliability. Just now I mentioned the server's reliability is higher than traditional air cooling data centers, and for system reliability, I think it's the same rule with the traditional water system or air cooling system. It's the same, maybe Tier 3 or hybrid Tier 3 and Type 4.
Yeah, I can add comments about this question. Right? So, because we are looking for the flexibility of our sites, the site selection, right? Another is really seeking on the electricity cost. Right? So that's why we have the three phases. This is the project, right? Phase 1 is the pilot. Phase 2 is the certain level, right? So then once we pass the second phase, we are going to deploy the solution. So that's how we convince our executive team.
How large do you want to go? How big? 20 megawatts?
I think that's we don't know the answer yet, right? Decide where is the site location. So it's suppose you go to Thailand, right? So those are hot area, right? You have more send server that would be used in mission. It really depends on where the location. Depends on what is the electricity cost. Depends on what's the space cost. So that's multiple factors. We'll decide what's our final decision. Because in Alibaba we have almost 500 million users, right, on our platform. So we need to provide the best solution, the quick response, and the lower cost for our customer. That's how we decide to go to
the time to market, I guess, for implementing this solution, is do you see it as a hindrance compared to traditional? With all the extra that you have to do compared to rolling a rack in an air. I know it's, in my mind, I guess, if you got a traditional data center, there was a whole bunch of time to market stuff that you don't count in, but this seems like every time you put a new rack in, you got to run piping to the roof and all that stuff seems like there's more work every time you put a new rack in than rolling the rack in. But what's the difference, I guess, in time to put a new rack in?
Yeah, so that one, we haven't had the conclusion yet. Right? So I just mentioned we are in the phase 2 right now. So by the middle of the next year, we're going to have the better understanding. So from a deployment standpoint, from the implementation standpoint.
So, okay, so when you figure that out, once you figure that out, are y'all thinking about pushing the servers harder? Now that you know that you can cool them, and now you can start overclocking them and pushing the tech harder, because now you have the ability to cool them.
Yeah, I think so. And not just the traditional server, right? So because Alibaba is also focused on the AI, so artificial intelligence, machine learning, not just the Intel, those OCP, right? We also use FPU and PGA. So that's a big challenge for the cooling problem. So our company is because in the people's mind, we are still the e-commerce company, right? The IPO year 2014, people understand it's e-commerce. But since the past 3 years, we converted from e-commerce company to a data company. So our goal is to be the world #1 data company. So that's our. We on the top of e-commerce, we have this our cloud. We transfer to the data company. That's the reason we would like to try to give them technology.
So here's the essential driving factor is performance of the CPU. If you want to handle this amount of data, which is beyond what they're currently handling, it will suck that much of power, which requires new technology to cool this power. Otherwise, you reach the root of the maximum capability. If the air-cooled technology will be able to handle, like, let's say it's 15 or 20 kilowatts per rack, you got to go to the next level, 30 or 50 or 60. That's overall, you have to look at like liquid cooling as more efficient way to cool it. And overall, I think in the long run, and also looking at CapEx plus OpEx as a total TCO to operate this kind of data processing system, if you will say that. But in terms of deployment, that probably will come as a second question when you really deploy this technology.
Yeah, it'll be interesting to see a financial analysis of you could purchase so many less servers because you were able to get more processing out of the liquid cooled ones.
Yeah, so to back to your question at the beginning, I think right now at this point, the speed of deployment probably is not the most important question to answer. It will be like a more technical question after they have the overall analysis of DCD of this technology. Because right now there's the pilot stage, as far as I know.
Yeah, we just passed the pilot stage with a certain level of deployment.
So really, if you just want to swap the 15 rack air cooler to a liquid cooler, it makes no sense. It has to be a much larger capability that you can handle, compared to the traditional air cooler. It has to be up to the next stage. It makes no sense.
If you think you want to do a much bigger footprint and then cap it at some level, so that then you can then overclock all that processing power to the next generation. So then you can take a 40 kW rack and turn it to an 80 kW rack.
Yeah, we don't know the answer yet. We don't, maybe next time or next year we will have more data, thanks to more insight. We don't have the answer to the question.
We have a Bunger.
Different time, different.
One question I have, you listed, I like the table that you had of the pluses and the minuses, that was great.
Mm-hmm.
And one was weight, right?
Yeah.
So what, as you do your pilot and stuff, what kind, are you doing anything special to take that into account? Special things you have to do to manage the heavier.
That's a good question. It depends on the if the building is newly built or just or existing building to reconstruction. If reconstruction, maybe the heavy is very the weight is very important for some. Yeah. Reinforcement maybe need to do it, but for new building, it's no problem.
Okay.
Yeah.
So the construction standards for new buildings are generally good for the expected weight.
Yeah.
Okay.
Not too much difference. Yeah. And, no question?
Anything online? We're good. One other interesting thing that I picked up what you said is you talk about, hey, if you could put your data center anywhere, right? Clean environment, air cooling, but you need it to be down in the, the southeast. And as you hear all this talk about edge computing and the compute needing to be near the users, I don't know, you can see the requirement for something like this increasing.
Yeah, of course, the time delay is always the important factor.
Yeah.
That's because network latency.
Yeah.
That's why you need close to your customer.
Great.
Okay. Thank you.
Thank you. All right.
Now, don't everybody leave now. It's that was the. Yeah. Okay, I really do want to thank Alibaba for presenting. I don't know if there's maybe some folks from the foundation. I think from an end user perspective, this is one of the first speaking and contribution I think that the foundation's had, and so it's a really big deal to get the experience because you guys are building very, very massive data centers on the other side of the world, so it's great to learn. So I think based upon what you said, we're going to be anticipating everything that you're learning along the way. So hopefully at the summit, I think that's in March, we can hear from you again and see how things are going. Just kind of a funny note at the beginning, I talked to Keith, who had done a lot of work on the assessment process for that. He's doing this running 1 mile a day, so he said he'd take a picture. So this is why he couldn't come to speak at the conference, and that is in front of a pub, just to let you know. So there he is. I don't know which one he is. I've never met him, but it was a while ago. I'd like to open this up to see especially from, the end users, what kind of things do you think the data center project should be working on? And I know none of you are going to want to say anything, because as soon as you say anything, we're going to ask you to actually contribute that thought to it. But no, just, yeah, what kind of stuff is most interesting for you for the data center facility? I think the learnings that we're going to get from liquid cooling is great. The last call that I had, there was some talk about, DSIM, the monitoring of the data center. Is there any kind of, open source stuff, or how do we do that? And I think Redfish is in the mix there to kind of maybe help standardize some of the schema that's done to talk not only to the IT equipment, but also the facility. Any other thoughts that you guys have?
Yeah, to that point, a lot of the equipment, speaks their standards, and they speak, what is that, something bus?
Modbus.
Modbus, right? So getting the standardization on, I apologize to those Modbus lovers, but more modern network and,
yeah.
That sort of thing would be very good.
Has anybody here taken a look at what Redfish is about? It's a RESTful API. Does that kind of meet the needs of what you'd expect for monitoring in the facility equipment? All right, well, take a look at it, see what you think. I think Zahl, at least you think so, right? Yeah.
Anything that avoids serial connections would be good.
What's that?
Anything that avoids serial
Avoid serial connections. Yep. Got it.
And I think the Redfish profile that they're working on is on our hardware management project group, so it's on their wiki. You can take a quick look at it. I think it's like 400 different items, line items right now.
Yep.
That they're trying to scale down to something under 200 to make it manageable. I believe that there's going to be redfish profiles for servers, as well as telco products, as well as networking, as, storage, because each one has slightly different requirements. So we're working through that, but if you want to take a look at the initial redfish profile, you can go to the hardware management project, and then go through their wiki and find it.
Great, okay. Parallel to that, they have been working on profiles for data center equipment, and they kind of worked through the green grid on that since there was a lot of facilities. So that is published as a draft spec on the DMTF website, so you guys can check that out. So it's rack PDUs, UPSs, power supplies, ATSs, transformers, generators, crack units, chillers. They've at least a baseline initial spec for that stuff. So.
And I think BMC is also being talked about as well. So there's the Open BMC movement that's going on with Microsoft, Intel, Facebook, Google, and IBM to try and figure out a unified version of BMC that would be applicable for, again, server compute, storage, networking nodes as well. So I think that's also being worked on to find out.
Okay.
So, again, hardware project management group, or hardware management project group.
Great.
Yeah, just to belabor the point, so I work at Microsoft, and like all of our IT equipment is managed via, is or will soon be managed by a redfish. Right?
Okay.
And then every once in a while we'll buy something and it's got this Modbus thing on. Hey, can you go off and spin it and at least put Ethernet on it? And then we're off working with the companies to get, okay, what's this custom protocol? Or, we would love to help somebody who's got a controller or a control system who would give you schematics and board files, open BMC, code stack, and everything. If that became part of your, part of your product portfolio. So you could have your Modbus version, and then you could have an open BMC redfish application. I think that would just be awesome. It makes it a whole lot easier for us to pull in equipment.
And from an OCP perspective, it makes it easier for our communities to consume that equipment and design to it, so the suppliers can design to it, and the users can consume it. Just so we're very anxious to get any kind of input that you have if you're working on it, either privately or if you're using a public, fork for it or a repo for it, like an IBM or a Facebook repo. We'd love to hear from you.
Yeah. Other suggestions that have been thrown out are kind of on the operation side. Maybe there's the software or even procedures on whether it's tracking equipment or maintenance procedures or things like that that could help. Open source maintenance tracking system or something. I don't know. I was thinking of your barcoding scanning software too, as a thought.
That way, anybody wants to make it happen.
And that's tracks and all the connections in equipment.
Yeah, it's all HTML5 too. So I'm going to work on the BlackBerry or with something.
I don't know.
I get the okay from
Yeah, talk to your team. I don't know if anybody else would find that interesting, but that might be a neat thing that somebody can go out and just immediately use as a tracking system. Cool. All right, what else? What else do you guys need?
We're still working on a environmental sensory monitoring system with Raspberry Pis and sensors on the front and back of the rack. I don't know if we're ready enough to bring it to OCP or not. So it works. We've got it deployed on 50 racks or so. see if it's ready to bring it. I'm hoping for March. If it is, then I think we bring it to the data center track.
You take it to GitHub now.
Yeah.
Doesn't have to be done.
No, okay. I'm not, oh yeah, it's not ready to go to GitHub yet. The code's not ready.
That's the point of community development, right?
Well, our code is not ready to be given out yet. There's too much Fidelity stuff in there yet. But the boards and stuff are all ready to be given out. And it was always intended to come to OCP. It's one of these ready to get out. But if anybody's, there's been a couple people inside of OCP that's tried to do or has been working on environmental learning into the rack. We've continued on, got some stuff going. If anybody else is working on that, I'd love to see that stuff too.
Great. All right. Okay, so from a scheduled perspective, we still have our monthly calls, third Thursday of every month. It's on the website. You can come and just listen in or come and participate if you have a neat idea you want to present. Just let me know and we'll get you on the schedule. So the next workshop we're going to have, looks like we're on track to do a data center workshop at DCD London. So if you want to present there, we'll get, and we got a very active group in Europe, which is fantastic. And then I think the next one after that is most likely going to be at the summit, I believe, because I don't think we have anything. There's a DCD Canada, but I don't know if we'll have enough people to go meet up there.
I think the next one will be summit after.
Yeah. Great. So that's all I have. I appreciate everybody coming by. I don't know if Foundation, you want to?
No, the happy hour is just because that's really important and top of mind. is starting at 5:30 and it's literally the last door as you walk out the hallway. It's right in front of you. Just keep going until you end up bumping into the bar, and that's that. And then the other thing that I was going to say is from a community perspective, we're always looking for new projects. And so if there are projects out there that you are, not seeing, that, apply to the data center but not quite covered by OCP, please do bring it to Bill or my attention or Rob's attention, and we would love to consider them. Because right now, we've got our fixed eight or so projects that we're working on right now, but if there's something out there that you see a need for, but it's not being addressed by OCP, that you think would be valuable to the OCP community, definitely bring it to our attention.
Yeah, and if there's something you're not sure, you want to bring it into the whole public forum of a work group presentation, you can always talk to Archana and those guys first and kind of feel out the thing if that makes you more comfortable. So, great.
Thank you so much.
See you guys at happy hour. All right.